Hi, in this video, we're going to introduce GRE, Generic Routing Encapsulation, and also look at how to configure a GRE tunnel. Okay, so GRE, Generic Routing Encapsulation. This is just the tunnel. It doesn't do the security. We use something like IPsec for that. So this is for site-to-site VPNs. We'll take a look at how we do this. It was developed by Cisco. It creates a tunnel for transportation of multi-protocols so that we can run both unicast or multi-protocol, different protocols, IPv4 and IPv6. And, but I was getting ahead of myself, IP multicast. So not just unicast traffic, but multicast traffic. That's important for routing updates and routing messages that use like OSPF and EIGRP that use multicast addressing. Okay, so the most common use case for tunnels to connect geographically separate sites over an existing network, usually the internet. So when we talk about things like tunnels, I want to introduce you to a couple of terms and concepts we call overlay networks and underlay networks. So when we create like a tunnel, what we're doing is it makes it look like kind of that these two sites here, this center and this center, are connected point-to-point links. Like there's just a tunnel between them that goes through the cloud, that they're directly connected. So this is an overlay network on top of or in this case, a tunnel. And what is below it is known as the underlay network. This is actually the physical infrastructure, what it really looks like. So although we have a tunnel that it's actually going through with our VPN, really what's happening is it's actually, the packets are actually being routed across multiple devices and multiple networks. But to these devices, to the end devices that are using this overlay tunnel, it looks like a point-to-point network. You can see kind of another variety of this. I actually grabbed this from Wikipedia, which is a nice way to kind of how we see different overlay networks. So here's our kind of our site layer where we have the different buildings, and we have an optical layer. So this shows the various optical devices that interconnect our fiber optic network. But from the perspective of SONET or SDH, it doesn't see all these things like repeaters and stuff. It just sees the SONET ring itself. And at the IP layer, it doesn't even see these. From the IP layer, what it's looking at, it just sees the routers, layer 3. So we can see how all this stuff is built, kind of one overlay on another, just what kind of perspective you're looking at the network. But the terms overlay and underlay, you're going to hear those throughout your career. All right. Let's move on with the GRE stuff. So GRE tunnels provide an interface, allow the interface to forward data through this tunnel, this connection between the two endpoints. And we're going to see how you configure this in just a moment. Okay, the data at the far end here, I'm sorry, this whole gray part here is the passenger protocol itself. Well, let's get into this. So tunnels are comprised of three main components. We have the transport protocol. So this is what's being used for the tunnel itself, in this case, IP. Okay, so this is the transport protocol. The carrier protocol is GRE. Okay, this is known as the carrier protocol. And then we have the passenger protocol itself, or the payload packet. This is the original IP packet that we want to send through the tunnel. The tunnel is being provided via the transport protocol and the carrier protocol. Okay, so some GRE characteristics. There isn't a RFC for it, 2784. The outer IP header protocol field would use the in the IP header protocol field would use a 47 to indicate that it is carrying GRE protocol. Then the GRE has a protocol field that indicates whether it's carrying IPv4 or IPv6. So we can see the hex values for that, 800 and 8DD. Okay. And IP, if we really want to continue this, would have a protocol field here. The payload packet itself, the passenger protocol, would actually have a 6 saying I'm carrying TCP. Okay, GRE is stateless, which means that both tunnel endpoints, neither one of them keep any information about the state or the availability of the other end. And it does not include any security mechanisms in and of itself. If you want that, use something like IPsec to encapsulate the IP and authenticate the IP packet itself. Okay, that would be the original payload packet you want to encapsulate, the passenger protocol. The GRE header creates at least 24 bytes, so we can see that, the tunnel IP header, GRE flags, and the protocol type. Okay, so that's in the GRE header itself. All right, so let's take a look at how we'd actually use this. So here we have just a regular network where, let's say, we're routing OSPF. And we have a packet to deliver from 10.1.10.55 to 10.1.2.105. In our network, it would just be routed as normal. Okay? All right, nothing big there, but what if we had a situation like this? That the source of the packet is on one part of the internet, and the other branches, the destination in this case, is not within that same physical environment, but it's a branch office that we connect to via the internet. But notice that we're using, and this is very common, private IP address space. Okay, so just like we did here, private IPv4 address space, and hopefully we're transitioning to IPv6, but we can maintain our private IPv4 address space, but we want to send this packet from the 10.1.10.0/24 subnet over to the 10.1.2.0.24 subnet, but we want to do that via the internet. So what we're going to do is we want to maintain this packet just as if we were doing this, okay? So we want to just send this packet just as if we were in this type of environment. All right. So what we do is that we are going to encapsulate that packet inside another packet. Encapsulating one packet inside another packet is known as tunneling. So we're going to put it through a tunnel. And the way that we're creating this tunnel is that we're going to have encapsulate the IP packet in a new IP packet along with a GRE header in between. Okay. And you can see the source and destination addresses that we're using here are the actual public IPv4 addresses, in this case, of either end of the tunnel. When the packet arrives at the other end, the purple IP header and the GRE header are removed. So it looks like they're just in the same physical network that we saw earlier. Okay, so how do we configure this? Okay, so let's take a look on router R1. Okay, we're going to do serial 000 here. We have a physical IPv4 address there, public IPv4 address that is connected to our ISP, to the internet. Okay, next we're going to create a virtual interface, an interface tunnel 0. So we're going to create the tunnel. Tunnel mode GRE IP is, I won't go into that command here, but it's an optional command. But we're going to give the IP address. Okay. I would typically say tunnel mode GRE IPv4 or IPv6 here, or both, just to manually specify that we're using a GRE tunnel. Okay, IP address. So now this is going to be the a private address, part of our private address space that we're going to see how we route for this in a moment, but this would just be as if I can do this very quickly here. This is as if we were creating this link here, the 10150, as if we had this link here in our own private network domain. We're just creating that using the tunnel. Okay. All right, the tunnel source is the actual public-facing IP address, IPv4 address in this case. The tunnel destination is the public address at the other end. Okay. Then we need to route for it. So we need to route both, just like we do for just like we need to do for regular OSPF in this case, are directly connected networks, and that includes our tunnel interface. All right, so we have one for our tunnel interface and one for our LAN interface. And if we had other directly connected interfaces in the 10.1 or any other network that we want to include in the routing, we would do that as well. So this is just like routing over a regular OSPF routing domain. Here's the other end here. Okay, so you can see a similar configuration for router R2. Okay, so as far as verification, show IP interface brief, we'll see our tunnel 0, and we'll see the IP address that we used for that. Not sure it's using the same ones I used in this example, but that's okay. Show interface tunnel tells us the tunnel is up and up, the IP address associated with the tunnel. It tells us what the tunnel source and destination addresses are, and also that we're using for our tunnel protocol transport is GRE IP, IPv4. Show IP OSPF neighbor. So we see our neighbor, and it actually has the public IPv4 address at the other end, but it says the interface that we're reaching that is via tunnel 0. All right, so that's an introduction to GRE and how to encapsulate these IP packet over another IP packet, which is really just basics of tunneling. So if you understand the GRE tunnel, anytime you have to work with any kind of tunneling protocol, they're basically all very similar.